Hello everyone, welcome to this class. Let us look into this problem of mathematics and see how to solve it. Find the value of 0.423. 23 is recurring. That is why dotted line is on top of 2 and 3. Let us make it more clear like this. In the form of P by Q, where P and Q is whole number. So let us start 0.423. How you can extend it? 0.423, as this is recurring, indicating the recurring, so 2 3 will keep recurring. Again 2 3, again 2 3, and so on till infinity. We can further simplify this by writing 0.4 plus 0.023 plus 0.00023 plus 0.0000023 and so on till infinity. We can express this 23 by 1000. Let us start from the first term only, because your approach should be you should get the number in this form. So convert all the number in that form. 4 by 10, 23 by 1000, 23 by 100,000, 23 by 100,000 till infinity. Can we make it more simple by taking 23 by 1000 outside? You can see here that ratio between second term and the first term. Second term and the first term. This one is your 1 by 100 and this is 1. If you take the ratio of third term and second term, third term is again it is coming equal to R. So every next term when divided by the previous term, the ratio R is coming same. So this type of series of numbers, are called to be in geometric progression, GP in short form. So what is the first term of this GP? First term is 1 and common ratio is 1 by 100. So you have this information. If we give the name, the first term as A, so it will be 1 and common ratio is 1 by 100. We have a formula for geometrical progression. If you have n number of geometrical progression numbers, the sum of that n numbers is equal to first term in bracket 1 minus common ratio to the power n, because there are n terms involved. So for this case, we have the value of common ratio, we have the value of first term. So we can apply this formula to get the sum of these numbers in bracket. So let us apply that. 4 by 10 plus 23 by 1000 into A. A is 1. A is 1. 1 minus R to the power n. 100. And this is infinity. Divided by 1 minus 100. So this has become your 4 by 10, 23 by 1000. When a number is less than 1 and raised to the power infinite, means multiplied infinite times, the value of that becomes 0. So our this term will become 0. So in bracket we will be getting in numerator this much, and 1 minus 100, 100 minus 1, this sorry, this will be your 99 divided by 100. Cancel out. 4 by 10 plus 23 by 990. 99 times 4, 396 plus 23, 639, 9 to 11, 419, 990. So this is in the form of P by Q. So our answer will be this. Just think of if we would not have known about the sum of GP series, it would have been a very tremendous task to solve this. So this series and how to tackle when we are encountering such kind of series in summing up or dealing with it makes the things simple. So now let us see how this part has come. How do we know that the sum of n terms of geometrical series, and that series first term is A and common ratio is r will be this much. Let us write a GP series whose first term is A, second term is AR, third term is A into R square, fourth term is A into R cube, and so on. So you see, when you are writing the second term, if you write second term like this, T2, so your number is AR, second term minus 1, that is AR. When you are writing third term, your number becomes AR square. When you are writing fourth term minus 1, so it becomes AR cube. So it means if we go like this and we say nth term, how can we write the nth term? So we have to do simply write the first term, multiply it with the common ratio r to the power n term minus 1. This is your nth term. Now let's go for digging into how these terms can be summed up. Let's say sum of n terms of GP series like this is S subscript n. S represent for sum, subscript n represent there are n number of terms for summing up. So your first term is A, second term is AR, third term is A square, fourth term is AR cube, n minus 1 term will be AR n minus 2, A to the power n minus 1 is the nth term. So can we sum these numbers like this? It is very difficult. Even if the digits are given, like okay, 2, 6, 12, 24, like this till n, it is very difficult to sum up. So what should be the way to find it? So we should find a way by which we should be able to cancel out most of the terms of it and reduce it to 2 or 3 terms, so that it will become easier to sum up. So if you notice, if I multiply Sn with R, so what will happen? This will become AR, this will become AR square, this will become AR cube, this will become AR4, and so on. And if we subtract those two, so your AR will cancel, AR square will cancel, AR cube will cancel. Till here it will cancel. So you will be left with only 2 terms. So let us do that. Multiply Sn with R. So your A becomes AR square, AR cube, n minus 1, AR to the power n. And subtract these two equations. Put the minus n. You can easily see that AR and this will cancel out. This and this will cancel out. This and this will cancel out. Similarly, this will cancel out from this term. Here, this term will cancel out from this term. This will be from this term. So you are left with A ARN. So your equation becomes Sn minus Rsn A minus A to the power Rn. Take common. So you have reached to the same equation which we used in the previous problem for solving. So this is the general equation for a geometric progression series of numbers when the n terms are sum. The result comes like this: a into in bracket 1 minus r to the power n bracket close divided by 1 minus r. So this is the tool which we can use when such kind of large number of summations are encountered. So this is one of the tools for GP series. If you would have not known or discovered this, it was very difficult to sum up the number like this. It was a tedious task. So knowing this or solving this and reaching to this expression has given a kind of tool to utilize it to shorten the calculation. So hope you are getting the crust how to play with the numbers or mathematics. So this is a small part which I have imparted here, which I have tried to give it or shared with you guys. Hope you enjoyed the session. Thank you.